So this is page 6. So we have a compound interest formula. Remember, there are two compound interest formulas. One is for continuously compounded. Continuously. I'm going to put that one first because that's what they ask for first. Anyway, continuously is A equals P e to the RT, like that. The other one is compound interest. Depends on how many times you're compounding it in a year. I think they just call it that formula. Anyway, it's A equals P times 1 plus R over N to the NT. Okay, so remember those are those exponents. Again, you can go back and look these formulas up, but these are compound interest formulas. R stands for the rate of interest, P stands for the principal, N stands for the number of times you're compounding, and T is the years. Okay, so we'll go through that. Use the compound interest formulas to answer the question. You decide to invest 40,000. Okay, that's the P. For 5 years, that's the T. At an annual rate. Okay, so where can I write that? The rate is going to be, you have to change it to a decimal, 0.022. Okay? How much more is the return if the interest is compounded continuously? So we'll use this formula for continuously, than if it's compounded monthly. If it's monthly, n equals 12. And we're going to round to the nearest penny. Okay, so we'll do the continuously first. And so the amount that you get after 5 years, we're going to figure that by taking 40,000, the principal, E, and then the exponent is R, 0.022 times 5. Okay? So that is going to go in a calculator, 40,000 E to the power of 0.022 times, they usually use like a little asterisk star for times 5. Okay, so you can put that in a calculator, you can do it in pieces. When I did it, I got, and I'm going to go to the nearest penny, $44,651.12. Okay, that's what I got. So that would be how much money then after 5 years I'd earn about $4,651. So not bad, just letting your money sit around. Okay, and the trick is to keep, start early when you're young and get it to grow early so you can retire. Okay, now we're going to do it if it's compounded monthly, meaning N is 12. Monthly would be 12 times a year. 40,000 for the P, 1 plus the rate 0.022 divided by 12, and then we're raising that to the power of, and you could just put your little exponent there, but it's going to be like, this is how you'd put it in a calculator. You can just type this all in a scientific calculator. I have a scientific calculator on my phone, so you can do that. It's going to be 12 times 5. And when I did that, I got the amount to be $44,646.63. Okay, so it's going to be less money if you're compounding monthly than if you're compounding continuously. Okay, now what's the difference? So you have to subtract these. So what's $44,651.12 minus $44,646.63? So it says, how much more interest did you earn in the continuous? So that's why we're finding the difference here. It turned out to be $4.49. So not that much more. That's why you don't see continuously compounded too much anymore, I don't think. But anyway, you make $4.49 more. Okay. Now we're going to graph logarithms. Okay, to graph them, the easiest way to do it is think of f of x as y, and then change it, rewrite it in exponential notation. This is something you should be able to do for the final or for the exam. 2 is your base, the exponent is y, equals x. And then what you do is you make a table of values, but you're picking y values. So pick like -1, 0, 1, 2, 3, something like that, and plug those in. You're going to calculate the x values. So what's 2 to the power of -1? That's 1/2. What's 2 to the 0? 1. And 2 to the first is going to be 2. 2 squared is 4. 2 cubed is 8. Now, the tricky thing is when you go to graph these, you got to do x, y, okay? So you're going to go over 1/2 and down 1. You're going to go 1, 0, which would be right there. 2, 1, and 4, 2, there. And then 8, 3 would be there. So it's going to go like this. And that's what a logarithmic function looks like. You actually have an asymptote here, a vertical asymptote going like that. Okay. All right. Now think transformations. What does this do? What does the x minus 3 do? It's going to shift 3 to the right. And 4, the 4 plus 4 is going to go 4. So then you're just going to move, you can move your asymptote, that's easiest first. Move it to the right 3, so it's going to be like right there. And then think about all those points shifting over 4 and up 1. So you're going to have a point there, and then you're going to take your point that was at 4, 2. Or did I not do 2, 2? No, 2, 1. Okay, so 2, 1 is going to go become 5, 5. 1, 2, 1, 2, 3, 4, 5, and up. Oh, you know what? I didn't shift it up 4. I only shifted it up 1. That's my problem. Get that out of there. Okay, so we'll go back to your 1, 0 now is going to become the point. So 3 to the right is going to become 4, 4. All right. And so 4, 1, 2, up there. And then your point 2, 1 is going to become, so go 3 to the right, that makes it 5. And then up 4, so that makes it 5 because 1 plus 4. All right, so 5, 5 is going to be right there. And then your 4, 2, it's going to go 3 over, so 7, and then up 5, 7. I'm sorry, no, we're only shifting it up 4. Dang it. All right, 6. So 7, 6. 7, 6, be like right there. And then you're kind of running out of room, but you could also do this one. So if you shifted it over 3, it'd be like 3.5. And then up 4 would be 3. -1 and 4 would be 3. So 3.5, 1, 2, 3 would be like right there. So you're getting a curve, something like that. That's just a way you can do it. You might have a better way to do it, but that's that one. Okay, that was the graphing. Now we're going to use the change of base. So change of base says you can change it whatever base you want. So if you have log base b of m, you can change it to, whatever base you want. Or a, I think they use a in the book, of m over log a of b. So it's like you split. Like in this case, for our problem, 15 is going to go to the numerator, 6 is going to go to the denominator. You can either use common log or natural log. I have a tendency to usually use common log, but natural log is fine. Gives you the same answer. And then they want us to use a calculator and evaluate to 4 decimal places. So you type that in your calculator, and you're going to round off to the 4th place, 0.9152. The big thing on that is the parentheses. Make sure you close that parenthesis on the 15, the one I just erased. That one, you have to close that off, otherwise you won't get the right answer. Okay, so we're going to do it again. I'll do it with natural log this time. Natural log 70 divided by natural log 2. Type in your calculator. and you're going to round it off to 4 decimal places, 6.1293. Okay, so use your calculator and make sure you're getting those right. This is going to be a similar thing. They want us to solve for x. Well, if I write it in a logarithmic notation, I would write log base 13 of 260 equals x. Okay, so now it looks like the problems we had on the last one. So we can just split that into log 260 divided by log 13. Now, you can't divide those arguments. You have to put this in a calculator. And they only want us to go 2 decimal places this time. So I get 2.69. Okay,